Okay, so let's get started. So today I prepared a presentation for you about different ways to filter containers in C++, and this may sound like a simple problem, right? So you have a container, and you want to filter elements that match some predicate, and you want to return a new container. But why I was doing that, and this is actually based on my blog posts at the early of this year. I noticed that this is actually quite interesting problem, and by doing all of those and by applying those different techniques, we can actually learn a lot of different things related to C++, to modern C++, and we can also use some of the latest C++ features. So I hope that everyone will learn at least something from at least one maybe technique from this presentation. So if you don't know me, I'm Bartek. I'm author of a blog called.Filipek.com, and I've been blogging since 2011. But recently I switched to new domain, cppstories.com. So please join that website, and that's heavily updated. And I've been working since 2014 at Zara.com. So it's not with Z, but it's X, as you can see on this link here. And we are doing advanced document editors. Right now, we also have a document editor that you can run in the browser. And for example, this presentation is built in that editor. Okay. So the plan for the presentation is as follows. So let's first introduce the problem, and then we'll try to solve that with different techniques. The first is let's say brute force approach with raw loops, and then we'll gradually improve that. So adding C++ standard algorithms. And then we move to latest features of even C++20, like erasive concepts, ranges. We'll also think how to make this code generic. And then I have I think, quite nice experiment about adding some threads, and what is this a good problem to throw some thread and some threads and process this work at multiple cores in parallel. So we can also discuss that, and also at the end I have one bonus slide. Okay. So what's the problem? So we want to have a function that is quite simple. So it's filter. It takes a container. So let's say that. So this is a pseudocode. So it's not real C++, but it takes a container. Then it takes also a predicate, and then okay, I have to accept, and then when a given element of that container matches the predicate, then it will be added to the output, and then you will get a new filter, a new container at the end as a return value. As an example, here we have a vector of strings, and then then here is the code that uses this function, and it has lambda, which basically checks whether this element starts with this star, and if not, then we accept that. Or we reject that. So in this case, filtered container. So the output should contain all of the words without those stars. So that's very simple, and I guess that you can think about code that implements that very quickly. So let's first start with the basic example. So let's first start with the for loop, right? So here is Compiler Explorer. Is the font size okay, or should I make it bigger or smaller? Maybe not smaller. Okay, so here is this function. Of course, here is this function implemented. So it's not pseudocode; it's real C++. So for simplicity, right now I'm starting as a template function that takes a functor, right? So that takes not functor but a callable object to be more precise, and then it takes vector of strings, right? So this is this basic example that I had on the slide. So of course, what we can do with this raw loop is to implement a basic version. So we have out, and then we iterate through this vector, right? And then if this element matches the predicate, then we add that to the vector, right? Okay. So hopefully that will compile, and as you can see, we have just 4 lines of code, and it should work as expected, right? So we removed all of those elements that. Okay. So it removed all of those elements that didn't match our predicate here, and so of course it's very simple, and like I mentioned, maybe this is a brute force approach, but of course we also can actually so this version that I implemented, and also but also we can actually admit and so pay attention to one detail that we have since C++11 is this auto type deduction, right? And range based for loops, right? So for example, before C++11, we had to write this kind of code. So we didn't have this auto type deduction, right? So we had to specify the full type as you can see, so we have to pass, we have to use, in this case, iterators, right? So it was, and this is just a very simple function, right? So I hope that, I don't know if you remember those times, or do you still have such code that where you have to use those kind of explicit complicated types, but right now, thanks to auto type deduction, we can simplify code even more, and it's getting better and better with each version of C++. So for example, this basic version that we have so takes vector of strings, right? But we can also make it more generic. So let's say step by step, and instead of vector of strings, we can take vector of t, and then what we can also do is use, and okay, and here is this one change, and also we can use, so since C++14 we have this auto type deduction, auto return type deduction. So so the compiler can figure out the exact return type of the function, right? So this is also very handy, and especially for template, for function templates, right? Later, so let's for now stick with the vector of t. but later we will try to make it even more generic with any kind of container. Okay. So those are raw loops, but since I guess if you have you seen this presentation from so this is CPP-Con, but I'm not sure if that was 2013 or 2012 or later. So Sean Parent about not using raw loops. So who have seen that? Or is there anyone who hasn't seen that? Mhm. Yeah, so Sean make a statement that we should aim for code without any raw loops, right? And so this is considered. Mhm, 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 yes. So basically, um, of course, this is quite simple code, but it does a specific thing, and maybe we can find another function or utility or whatever that actually does what the function says. And so the main thing was to find some helper functions, most probably from the standard library, and probably that will be also there is this joke that you can change everything into stud rotate, right? So that's also something that he mentioned. But apart from stud rotate, this kind of code can be easily changed into stud copy, right? Stud copy if actually. So in this case, we have existing algorithm, right? And so we pass begin and end of our container, and then so if we go to this, I don't know if it shows the full. There is no syntax so function helpers, but so I won't show it, but I think that you know that. So here we can use stud. What was that? Or yes, back inserter. Okay, so basically, right now I changed this raw loop into so explicit code, right? So this previous loop actually did something, and I can name that, right? That was copying something and checking whether something matches a given predicate. And we have a function for that. We have copy if or stud copy, and depending on the version that you want to use and conditions. And so in this case, it's better to use existing algorithms, right? So in this presentation, I have also a reverse version, because we so in the C++ standard library we have a lot of good algorithms that we can use. And for example, for this case, we also have remove copy if, which is like a negation of what we had before. So copy if will copy everything that matches the predicate, but remove copy if copies all of those elements that doesn't that doesn't match our function. So in this case, to get the correct logic, we have to apply stud not fn, which inverses our predicate. And by the way, this not fn is part of C++ 17. I guess that previously we had functors like stud not one, not two, something like that. But right now it's replaced into a single helper function object called not fn, which makes an inverse of a given callable object. Okay, so another technique that we can use is this famous or infamous remove erase idiom, which basically so you have to use stud remove if with quite similar syntax that we used previously, and then because of course remove if doesn't remove because that's C++, it only shifts elements to the end of the container. Then we have to actually erase, so call a erase function, erase member function actually on that vector to really physically remove those elements from the container. So this is I'm not sure if that's quite popular, but this is let's say quite efficient way to remove elements. So this is how it was in C++ for lots of years. But and as you can see, we have this slight change with those versions, with those techniques, because previously, let's say this basic copy if, so I only declared empty vector, right, and then I used bug inserter or something that basically does pushbacks, right? But now with this one, with erasure, so to say, I had to copy a vector first. So I'm doing more work, right? So I'm copying a vector, so the input vector, and then I'm erasing elements that doesn't match my predicate. So that's something to keep in mind. So that's some additional work. Maybe that will increase. So that will for sure decrease our performance. But it's a matter of our requirements, whether that's very important or not. But this is one change that actually I use here. And fortunately, since C++ 20, we have this let's say magic function erase if. That's so this is a non-member function or set of function overloads actually that transforms this remove erase idiom. So right now, since C++ 20 and a lot of compilers and standard library implementations already have that, so there is no need to use this remove erase idiom because you have this single function. So we can also actually this proposal which was added and accepted in C++ 20. So we can have a look, and so basically this proposal is called consistent erasure, right? And makes a set of functions, non-member functions, for all, so mostly for all containers in the standard library. Because as you can see, I'm not passing any begin and end or start and end iterators. This is just a single container. So it's almost like a range, right? So I'm passing the single container, and then based on the type of this container, as you can see here, we have erase if for basic string, for deck, for forward list, unordered maps, multi-sets, whatever, right? So it's mostly all of, and of course there is a vector somewhere here. Yeah, so here we have this vector because we have arrays and arrays if, right? So as you can see, for example, arrays, so this is equivalent to erase and remove. So in this case, arrays will erase all of the elements that doesn't that aren't this value, or we can pass a predicate. So this is quite nice, and right now we can actually think about making it more generic, right? Because we previously I used this arrays explicitly on vector, but not all of containers have arrays. I guess that's so I would have to check with this standard and with this proposal, but this function makes it available to have a single consistent method, right? What we can do also and take someone joins, okay. What we can do also and use some of the latest features is to try with ranges, and so since so ranges is a way to or a possibility to get away from using iterators. So instead of passing begin and end, you can just throw a range, which is a simple, let's say, pair of two iterators pointing to the begin of the range and to the end, or some special sentinel at the end, depending on the range implementation. And in simple examples, we can see that instead of passing begin and end of a given container, we can just pass a whole container, right? So like here, we can pass vector without begin and end, and then actually for this case, for ranges copy if, we have a very similar function, and it will also take some output iterator. In this case, this is also back inserter. So in most cases, there is an existing algorithm, existing or yeah, so there is a ranges version of standard algorithms that we have. So previously we had stud copy if, and right now we also have stud ranges copy if. Of course, you can still use stud copy if as before, but with ranges we can so ranges gives us only a possibility to make to compose let's say views and transformations quite easily, which wasn't that easy before. So for example, as you can see here, we can so let's say here we have this filter with ranges. So we have this pipe operator that takes, we can read that from left to right. So it takes input range. In this case, this is our input container, and then it applies a filter on that. So we have a lot of existing views that we can use. So for example, views filters, views take first 10, take or drop something, or transform. And then this is actually not real, because some parts of so ranges library is evolving. And so for example, in this blue code actually points to code that is not available in C++20. And here is actually a proposal to add that. But finally, when ranges will be ready, or will have all of the capabilities, let's say in C++23, we'll be able to transform everything and then put it again to a new vector. So ranges2 will convert this whole operation that happens before into a separate vector. So currently, for our experiments with C++20, what we can do is as I mentioned, we don't have this ranges2 function, but we can easily implement that by just iterating through this range. So what I have here is a similar code that I had before. So it iterates through a range which is composed of my input vector, and then I apply this filter function. And then I have to sort of manually push it back to so push it to some other container, to in this case this output container. So this is maybe not handy, not as handy as we could get, but still, and in theory you can also write this helper function on your own. But even with that, ranges adds quite fresh view on containers and operations on containers. What I like about containers is that you can basically experiment with them quite easily, right? So you have a function that uses some stud algorithms, and you can just look into documentation for ranges. So for example, on CPP reference, and then see whether there is a matching ranges function, ranges algorithm, and maybe replace that, right? And then you will start applying filters here and there, and then also building your sort of experience and confidence with filters. So like in this case, I applied a simple transformation. Okay. So I forgot to mention that if you have any questions, you can just shout, and we can answer it as it goes. Okay.
Okay, so I wanted just quickly to ask, and this view filter function, what does it return if not a vector?
Yeah, so it returns another range, right?
Oh,
because
okay.
yeah, so ranges are you can see that as a let's say in this case composition of those simple pairs of begin and end. So in this case we pass in this return statement at the end. So we pass begin and end. So by default, range created out of container takes begin and end of this container. Then it also creates another range that has the same iterators, but with additional filtering function in this case. But it's still so you can basically compose them together, and then at the end you can sort of invoke all of the computations that you created. So that was previously not possible with stud algorithms, right? Because you would have to do it step by step. So first, let's say transform, then filter, and then do something else. But with ranges, you can build those collections, and you can collect, let's say, collections or composed views and ranges, and then invoke the calculation. Yeah, so of course ranges are I just wanted to introduce it very quickly and sort of give you a hint that you can try, but I'm still learning how to apply them, but it's nice that you can apply them one by one and experiment. So that's quite nice.
Cool. Thank you. Thank you.
Okay, so equipped with arrays if from C++20 and also with ranges, we can make our function more generic, right? So, for example, in the first case, I have a function that's instead of taking stud vector of t, it takes t cont whatever that means. So that's a template parameter, and then it takes and then it uses arrays if to perform the final erasure, right? So assuming that there is matching arrays if for our container, so for example, if you don't pass it like just an int, then you should get this code working, and we can see that with all of those so 4 lines of code, we have used a lot of modern C++ functionalities and features like this auto return type deduction, auto type deduction for variables, and this arrays if, and even this small not fn from C++17. So this is quite nice. We can also but this function has this problem that you have to create a copy, right, of this output first, and then erase elements from that. But then we can also try with ranges. So the function signature is the same, and here we can use copy if and pass this vector and also this back inserter. Of course, ranges are not that required here, because we could also do that with stud copy if, right? So that's not super important. But the problem is that what if there is a container that doesn't support so basically pushback, right? So in basic example, that's map. So that's stud map or those tree-based, so node-based, so tree-based containers. So there is no pushback here. So how to make it more generic? So our function can handle, let's say, all of the containers and still be able to use, let's say, back inserter, or as a fallback, it will call inserter. So here's a simple or not simple case or example where we can try that. So basically, we have the same function that we had before, but right now I'm using if const expr. So this is something from C++17. So basically, at compile time, we want to ask whether this particular container has a pushback method, pushback member function. And if it has, then we can use inserter, and as a fallback, we will just use inserter for so if const expr, that's as I mentioned, C++17 functionality, and so this heavily simplifies let's say complicated template function. So during compilation, the compiler can perform various checks, and in this case, if a container has this pushback method, then this code path will be evaluated into, so it will be instantiated into final template function template, and this one will be sort of, we can perceive that as this will be discarded, right? And it will it won't be let's say compiled, right? So that's the general overview. So this is not runtime if, this is only for template instantiation, and on the other hand, if the code, if our function, if our container hasn't got a pushback member function, then this code will be discarded, and this code path will be let's say moved to the next stage of the template instantiation. So that's very handy, and it can simplify complicated template code. So previously we had to use techniques like tags, so compile time tag matching, or sFINAE techniques. So this is and we'll see that in a moment. So I mentioned that this code may look like that this is not compiled. So let's say that if the container has pushback, then this code is discarded, but still the compiler will have to look at the syntax, right, and check if the syntax is correct. So this is not like a macro or something simple. So the compiler will still check whether given given names, given so in basically syntax is correct, and then during the template instantiation, it will be simply discarded, like the same as if that was sFINAE or with tag dispatching. So that's something important to keep in mind. But in general, so you can see on my blog post I recently so updated this blog post about if_const_expr and how it can simplify code. So you can so I encourage you to see that, and if you want some more examples. Okay, so let's try. So I won't write that function from head, because I wonder if that's so. Here is example of that. Okay, so here is this filter copy if, and as you've seen on this slide, we can also okay, so let's for now let's keep it simple, and then what's the implementation of this function of this hash pushback? So basically I'm using so here we have this code that is available for C++17, and below you can see a code available for C++20, and basically the C++17 version uses sFINAE technique, so to generate so this is basically the deduction, so checking whether a given type has a member function. So in this case we create two structures. The first one, the first one is false, so derives from stud false type. So it's most generic specialization of that. So most generic templates for that structure. And then we have has pushback with a thing called stud void t. And basically the trick here is that we are passing this check that we want to so the expression that we want to check. So in this case, we can decipher that from let's say yeah, so from here. So here we are using decl value. So this is a special function that generates an object from a given type. So with decl value, we can pretend that we have an object of that type t, and then we call, then we can invoke, let's say, a pushback on that. But we want to pretend that we have a value of actually the value type of that container, right? Because we are assuming a container implementation, so that will have this value type. So the value type should be present. So if you pass an int, let's say, to this structure, and this will fail, right? Because integer doesn't have this pushback method. So it will fail, but it will fail in an svna way. So it will cause this template, so template specialization to be discarded, right? And so all we get, so this will be discarded, and only that will be available. So we can perceive it that way. But then if you pass here, let's say a stud vector, then it will have a pushback. So this whole expression will be valid, and has pushback will so becomes more specialized. So template specialization here, and this one will be preferred. So the compiler will take that, and then since it derives from true type, we can so it will basically return true in our condition. So here is also a variable template that makes it easier. This is also common in C++ 14 and C++ 17, that we can use many of those type traits with V or T, depending on the type trait. Okay, and so all in all, we can use that here. We can also try an experiment. So assuming this code path will be selected and compiler explorer compiles, we can see that for vector it will take this code path, right? But we can also let's say we can also have this set. And then, of course, I don't have. So if we have sets, then okay, I think that it will. Okay, and then can do something like that. So we are passing this set of strings. Oh, okay. Okay, I was worried because for a second it showed also that it selected the pushback pass. Okay. Okay, so as you can see here, the results. Okay, I have to connect my headset. Okay, so as you can see here, the results are the same. So it properly handled both cases. So it handled vectors and also string and also sets. We can also play with other containers, but of course, if we pass something like that, then yeah, then we will get. So this is still compiling. But as you can see, yeah, we tried to pass something that is really not valid. So in this case, this is not. So this is not not a vector, not any container. So it fails. Okay. But what I wanted to show you also is that we can move to concepts from C++ 20 and have much shorter code and so explicit also. So here in this case, I'm using. Hopefully it will compile. Yes. So it has. So here I'm creating concept which uses requires. So this is called requires expression, where I can easily check all of the things I want on a given type. So in this case, this looks almost like a regular function. So in this case, I'm taking t, so object of the type t, and I can check whether it has and whether it has given member variables or member functions. So in this case, I'm using t pushback. Unfortunately, I have to still use this complicated, let's say, t value type, but this is quite. This is not that super horrible. So what it does is this. So concept basically has this power of checking whether this this expression is valid, and if it is valid, then this whole concept will sort of return true, and if not, it will be false.
Bartek?
Is it? Yeah.
I think you could use this type as another argument to this require. This function like requires syntax. This way you wouldn't have to do this decl-val.
Yes. So okay, so let's leave it for later maybe, but basically I just wanted to show the simple transformation that you can express things much easier than with this complicated S-Finney tricks, as I like to say. And it's very easy to use, right? Because we can just yeah. So it's if you know how to use type traits, then concepts will be also quite easy to apply. So that's one transformation. But what's more, we can also throw some more concepts. And for example, with C++20, we have a lot of existing predefined concepts. So they are mostly based on existing type traits. So for example, here we can throw a stud predicate. I'm not sure if that's correct link. Let's try. So we can try to narrow narrow this. Okay, this transformation. So we can update this. Okay, this is not this one, but okay, I actually have that written here. So we can throw existing concept. So in this case, I requires that this predicate type is of type stud predicate, which is actually so unary predicate. So it takes only single value. So in this case, this is this T container value type, and then I can restrict my function to take only function objects of that type. What's more, predicate requires that return statement, so return value of return type of my function is sort of is called Boolean testable. So more or less we can treat it like whether it can be treated as a Boolean value. So whether it is true or false. So for example, I can, let's say, this is our function. What if we pass a function object that has that takes two arguments, right? So it failed, but the main advantage of concepts is that we have more or less better messages, right? So in this case, we have this required predicate. Sorry. And in this case, it requires that our lambda has only single argument, right? While we passed two arguments. So that's why it failed, right? So template substitution failed. So it's so those compiler errors are getting better, but and we can sometimes concepts win, sometimes old functions win, but still you can early on get the message that your particular concept is not valid. And so that's quite handy, and also we have a lot of those predefined concepts, so that's why it's quite yeah. So it's good to review them and also start using them before applying your own templates. Unfortunately, there is no concept for container, so I cannot specify T requires to be container. There is no such there is no such concept. But the closest we can get is that we can require that this container is range. Maybe that can somehow work, but that's sort of further discussion. Okay, so do you have any questions till so far we completed this section about let's say being single-threaded and using various techniques. So from copy if to ranges, concepts, to even raw loops. But that was still single-threaded. And right now, I'd like to move you to discussion whether it's worth to make it running concurrently. So do you have any questions related to this section? Okay. So since C++17, we have this thing called parallel algorithms, and basically, so in short, this is a new parameter to most of standard algorithms, where you can specify the execution, whether this is sequential, parallel, a par unsec, or just unsec. So basically, the first one, sequential, is sequential, so sec. Then we have execution par, which is parallel, and possibly to make it more efficient, this is on system thread pool. Okay. And then we have unsequenced. So this is mostly using vector instructions like SSE or AFAWIX, depending on the implementation and if that's possible. And so that those three were added in C++17, and in C++20 we have new execution helper unsect. So this is sequential, so on a single thread, but with vector instructions if possible. So that's something additional. So today I'd like to focus on those two things, or actually just a single one on the parallel execution, and we can write code that runs our copy function in parallel. So as I mentioned, these parallel algorithms are very simple to use. So what we can do is basically take an existing std algorithm and then throw this special first parameter. So in this case, I'm using for each, and then I'm using execution par to specify that I want to be executed on multiple threads. And then I'm using regular code, so begin, end, and then I'm calling my lambda to perform the operation. So it will go for each element, for each element, and then apply this functor, and then push it back to output container. So this looks nice, right? But so the first question is, so to you, how much slower that code is compared to a single so sequential version? Can you guess? So so let's say that the code on sequential version runs like, let's say, 10 milliseconds. So how slow this one will go? So can you predict? Any guesses? So is that, I don't know, the same also 10 milliseconds, or maybe 15 or 100 milliseconds?
It would execute slower.
Slower, but how much? So like from 10 to 15, or from 10 to 100 milliseconds? Of course, I didn't mention how many cores, but so for example, on my machine, so not this one, but other machine, I have, let's say, 6 cores. So in theory, we could get maximum speed up of 6 times, right? Okay, so after and of course, do you know what's the main problem with this code in terms of performance mostly?
Lock on each element.
It doesn't matter that. How do we parallelize this thing? Required to push them in a specific order into the container.
Yes. So that's one. Yes. So for example, we can assume that the final order doesn't matter, right? So we can get any order, and that's fine.
The thread, if it will be waiting for the lock, it will be pushed to the thread queue, and that will be most probably much longer than 10 milliseconds.
Yes, exactly. So the main problem is that we have to use some locking mechanism, right? Because otherwise, if I don't have this code, if I don't use mutex or some other locking primitive, then I'm risking that pushback may completely fail, and it can even crash, right? Because let's say that two threads can try to push back different elements at the same time, and pushback requires some memory reallocation sometimes. So that can be quite dangerous. So that's why I had to use unique lock to provide safety, right, and correctness. But of course, this one takes much longer than the sequential version. So that's quite stupid, naive approach. And in my case, on a vector of actually two doubles, right? So this is not just a vector of int, but this is vector of two doubles, pair of doubles of some size, like in this case it's 100,000. I got 3 times slower than the sequential version. So this is this par naive version that I got. So 3 times slower for a super amazing parallel algorithm. And to prove that my system works and parallel algorithms work, here is this transform those two lines. So this is a basic vector. So we have this vector of doubles, and then we have this transform, so stud transform. It basically runs through a vector, through this vector, and applies some sin and cos functions, so sinus and cosinus functions, to do some arbitrary computation. So in this case, as you can see, when I run the same code, the same execution in parallel, I got this 6 times speed up, or even yeah, so it's 5 times, let's say. So it's almost linear to the number of cores, of hardware cores that I have in my system. So that works, right? But this will only work when you have trivial code that's where each computation doesn't depend on other elements. So in this case, each element potentially depends on other elements, because this pushback has to be safe, right, and has to be in a critical section. So while maybe there is a chance that this line of code will be evaluated concurrently on multiple threads, then the following lines are not safe, and we have to protect them. So that's the main problem with the why that's slower. And what's more, it's not. As I mentioned here, I have a pair of doubles, and it might be not that easy to actually get any performance improvement. Sorry. So what I oh gosh, recently I had some some colds, and apparently I'm not fully healed. So what we can do here is we can be clever about the job that we can that we want to perform here. And my sort of small invention here is that we can take this input vector and do one thing that I can try as well. Try to shut down the window, so maybe it will improve. So we can be smarter about the computation that we can do here, and so I propose that we can, if we have this input vector and we want to filter out those magenta elements, what we can do is that we can create that function in multiple steps. So first of all, we can have this predicate run, and this will invoke this predicate function and store results. So those binary results in a separate vector, and then we can do a prefix scan to find the final position of those elements, and then we can copy those. So this prefix scan is basically so this is a sum of previous elements. So like here we have we have 1, and this is a sum of those two previous elements. So 0 and 1. Here we have 2 because it's 0 plus 1 plus 1, and as follows. So in this case, those we can then copy those elements. So the prefix scan appears to create the final position of the element if if the predicate is of course satisfied. This code, so I have here, and this is in Visual Studio because only Visual Studio as of now. So also GCC supports parallel algorithms, but Visual Studio is, let's say, nicer to use because in GCC you have to use Intel threading building blocks and combine them, link GCC with so link standard library with Intel TBB. So okay, so this is this function. So what I have here is that we transform those. So we run this predicate function over that collection, and then we store that in a separate vector in a buffer. And then we have this exclusive scan. This is a new function from standard library that we have, and the main advantage here is that it can be also specified with this execution parameter. And so there is a potential benefit of running it in parallel, and this is just one line of code, right? So that's quite simple. And then we have the final loop, so for each that is also executed in parallel, where if the buffer on a given position is valid, so that we don't have to run this predicate function again, we will just copy the values to the index specified by this index position. It's not easy, right? So it's definitely more lines of code than than our sequential functions. But as you can see on this on that slide on the summary, it quite so paid off, right? Because we have like, so previously we had it was 3 times slower, but right now it's almost 3 times faster than the sequential version. So going from 3 milliseconds, 3.5 into 1 millisecond, and then you can see several variations. So for example, here I have sequential, which is even faster. So this is the sequential, and here I do everything the same, but the final copy is sequential, right? So that's raw loop that we can write. So instead of parallel, I have raw loop, and that appears to be faster, at least for this case. And I have also version with chunks. So here is another version where we basically do the same job. So we call copy if on smaller chunks. So we call that in parallel, depending on the number of hardware concurrency. So that will get us a number of cores that we have in the system usually, or also so system threads sometimes, and then we can split the work, right? So then we will get chunks, so copied chunks, and then we can run this and insert them one by one to the final output, including this remaining part if there is something at the end, not divisible but by the number of chunks. So that's one approach. I also have a version with stood future. So it's more or less similar, but instead of using parallel algorithms, here we have this vector of futures, and so those tasks will be called asynchronously. So I'm running it quite quickly, because you can find, if you want some more details, you can find it on my blog, and source code is also available. But here is the basic summary. So this compose, so this version with this prefix scan is fastest, right, with the sequential scan, and then chunks are okay, but not that fast. So here we have bigger size. We can also see similar results, right? So it's baseline is 35. Okay, and here, thanks to John, supporter on my blog, he created a sort of final benchmark where he benchmarked all of the methods, all of the techniques. So here is so he had 4 cores on his laptop. So here we can compare. Then this sequential version is fastest, and then we have this, and then we have arrays if. So the generic methods appears to be fastest out of those sequential. Then arrays if, so those are similar, and then ranges copy if, right? So that's interesting, right? Because in those arrays if, we first have to copy the whole container, and then we remove elements, but with copy if we use pushback, so it appears that doing more work is actually beneficial here. That's probably because. So, do you have any guesses why it can be that way?
Have you tried to reserve the output vector before calling pushback?
Sorry, can you repeat?
Because if you are going pushback, the vector will be allocated multiple times. So
yes,
do you have tests with the reserves?
No, because you cannot reserve at that stage, right? So
you can reserve more.
Yeah, so because you have to guess, right? What's the final size, and maybe at the end you could shrink the vector, right? Yeah, so I don't have this test, but that's probably it, because arrays if copied all of the elements, so it was just one memory allocation, and then when we simply erased elements, then it was much faster than doing pushbacks and growing vector several times during the calculation. So that's probably it. But of course those differences are not huge. And what's important, it's still this benchmark is still done on the vector of this pair of bools of Boolean values. So those objects are like 128 bytes. Yeah, so it's bits, but it's yeah, so it's yes, so it's maybe super large, but still for integers we would probably see some smaller differences. So also the question is whether it's worth actually running that on multiple threads. So it look, so I paid some time to actually create that implementation, and maybe it's not worth, right? Because if you just perform computation of integers, then adding more threads will increase cost of the whole code, because for example, running parallel algorithms, so that's like invoking the whole infrastructure for thread pool or some other complicated mechanisms. So that's definitely more work than maybe maybe the best approach is, if you want to optimize that, maybe if you have a single worker thread, then maybe, and if you want to copy something, let's say off the main thread, then maybe it's good to just call that one action on that worker thread and then continue your main execution, and maybe it will be less time than running copy if on the whole computation. But still, it was quite nice experiment to perform. Okay, so that's mostly the last slide for this presentation. So do you have any other questions?
Yes.
My voice returned, so I can answer.
Yes, I have a question about versions with chunks. Can you show it again?
Yes. So
I think we can the size of chunks and resize the result vector, and would it better than insert chunks if we resize the vector before the last for cycle or not? Not resize or reserve the result. We can calculate sizes of chunks and result. Would it better or not?
Yes, so I have this. So for example, copied chunks. So they are sort of initialized. But then yes, I'm using those bug inserters again. Yes, so maybe here we can reserve and so we will throw away those vectors anyway. So yeah, so that's good optimization, right? To reserve and then at least for this part we will get better performance. So that should be.
And another questions about cache fault sharing. Can we have any problems with copied chunks vector with sharing and different threads access to the out vector of
so in this case, so do you mean that function that performs the main computation, or so that my main task? Because there is no sharing, so those chunks are computed separately by different threads. So there is no way to that they will access memory from. Or maybe I didn't understand the question properly. Okay, because the main idea of chunks is that we split the input data, and we do work in chunks and then try to merge into single output. Yeah, okay, but that's good point about this reserve. That maybe I can spend some time and add that to optimize. Okay, so I hope that you learned something, and we moved from raw loops into various different kinds of techniques, even for such a simple thing like copying data, right? So that's quite interesting that you can go.
I have.
That.
Have you tried to remove erase in the when the remove is run in the parallel?
So remove erase in this case, in this case of those,
yeah, just remove erase, but make remove put stud par on remove.
No, because I think that there is no implementation of remove if, or
yeah, I would expect that the implementation have for the chunks could work for remove if, so I'm just curious.
No. So I haven't tested. So of course the main reason why I implemented this whole thing is that copy if stud copy if in theory has parallel execution, at least in the specification, but it's not implemented in Visual Studio. So if you go to this implementation, then you will see that for now it's not implemented because it wasn't practical. So the Microsoft team actually decided that they won't implement that for now. I think that Intel TBB has an implementation for that, but not sure if that's available with GCC with GCC library. Yeah, so that was purely for experimentation, and I'm not sure whether you actually have to use it in production code, but but it's good to know that you have various options available. Okay, and I have this one slide. So apart from this presentation, I just wanted to mention that if you don't know, that C++20 is published. So it was published officially in December last year. So it was still C++20 2020. And then C++23 is actually ongoing, so it's ongoing project, and so if you can find compiler support in this great page on CPP reference, where some C++23 features are already listed. So it's quite amazing. So we have like two language features and set of library features. So relatively those are quite small, but still work is done. And you can see those trip reports, so virtual trip reports from Herbsutter. And yeah, so basically before pandemic, those ISO meetings were offline and so in some location, sometimes in Europe, sometimes in USA. But because of pandemic situation, they were moved completely to virtual meetings. So Andrzej and so Tomek, can you do you participate in those virtual meetings? I guess that it was like 200 meetings last year, something like that. So it's quite crazy amount of meetings going on.
Yeah, I mostly participate. Today was one just overlapping with the one we have. This one, so I wasn't there for the full meeting, but I'm mostly there.
Okay. Yeah. So depending on the group, you have different dates, right? And
they switch the hours. So this week's discussion was about granted copy relation for the return variables.
Okay.
So that was a pretty interesting topic, I would say. Not at least from what I see in Heaven's I've a lot of like positive feedback, but it was about if you have a function that declares vectors, do something with vector and returns that vector, as in your example. Are you required to move this vector? The paper was about guaranteeing that this vector will be not copied or moved at all.
Yes. Yeah, but so from your point, are those meetings as efficient as it was so offline and in real physical location, or?
Yeah, but you can. To give you an example, we spend like 5. In the library, there is one group that spends, let's say 8 hours, 7 hours for the 5 days plus half a day. 7 hours for, let's say 7 hours for 5 days, 55 hours. So you need a lot of weekly meeting to get the same amount of work. But I think that if you have like in every quarter, I think similar amount of work is done. But you have a lot of less group meetings. So for the groups that are meeting, that's fine. But you are missing a lot of groups that were meeting when the meetings were face-to-face, but now not meeting
face-to-face.
Okay. Yeah, so for example, library working group is running every week, basically. So like there is a lot of progress made on the library, I believe. like similar compared to the meeting between virtual plenaries. Evolution and liberal evolution also rules every week. I'm not sure about the call. I think they are running pretty frequently, but all the study groups are not really running so frequently. It depends on the study group, but there was like more work done because there was evolution in co-battles than there is, and so on.
Okay, so yeah,
so it's different, but it's easier to participate. That's the other thing.
But still, work is being done, right? So it's not that. So it's not
there will be a lot of,
right? Yeah.
I think the pipe is getting filled, so there will be some interesting stuff going, like having an ability to spell auto to just copy variable. So if you have some return type or the function, and it might be reference, it might be anything else, and you may want to make sure that you will make if you already get a temporary, you do not want to make a temporary, but if you don't get temporary, you want to make one, you can just spell auto and something in the parentheses to produce. Like calling stud vector to make new stud vector, can do it with the auto. So that's
okay. Yeah. Yeah. So Herb Sutter makes those trip reports. So hopefully we will get one for spring and summer. Okay, and of course there is so most of user groups moved to online, and so meeting C++. So Jens tries to keep that so keeps those groups running, and you have a list of for example user groups in May, and there will be a link to user groups meetings in June, and meeting C++ also created meeting C++ online, where you can participate, and I guess that they have like weekly meetings. So lots of great topics, and yeah, so basically you can pick any user group you like, and try to, and depending on the time zone, but you can actually watch a lot of presentations. Yeah. So also Andrzej, right? You were so last few weeks, right? You were on this C++ Now, right? And you mentioned that because of the moving C++ Now to online, you get like 150% more participants, right?
That's correct. More people are joining.
Yeah, so
to fly abroad.
Yeah, so I wonder whether that situation preserves after pandemic or not. So, for example, in ISO meetings, so face to face, so there is one scheduled. So it will be like next year, New York, I guess, right? So that's sort of more or less scheduled to be face to face. So first meeting after pandemic, but we'll see how it goes.
I would say that the first one that is not, because there are multiple groups that the standard committee is like both on the ISO part, but there are also we have various the standard committee has various organizations that put rules on them, and that are first meeting when there are no bans from any of the organization to create to have a meeting. But I believe that the meeting will be, so that's the first possible time when the meeting could be there. I believe that the planning is to have meetings, and but that's to be clear. There was like the ban was extended a lot of times for the face-to-face meeting. I hope it will not be extended. I think a lot of people are hoping for that we return to normal face-to-face meeting, but because that is very hard for the organizer, because as you are going there, you are not paying to, like, if you go to the conference, you are paying to conference, so the conference organizer have a way to pay for the hotels room, for example, hotel conference rooms, and for the meeting, for the committee meeting, that conference room are sponsored by some company usually. And it's hard if they need to like have a plans for that and need to resign from resign.
Yeah. So it's better. So it's better to wait and after all of everything. So all of the situation is cleared and.
Yeah, I'm not sure. It's always hard because then if you want to organize it, you need to like organize it in advance. But the question is if the ban will. So that's always hard. Both of our hosts, the host of the community, and also because they need to like adjust. But from also the standard committee. I forgot how they are named, officers. So also that's hard.
But fortunately, like C++20 was more or less completed in the last face-to-face meeting. So in Prague. So it was February last year. So it was so feature freeze and everything was completed. So the rest of work was mostly publication. So it could be done online, offline, without any special meetings. So fortunately, C++20 was published on time without any issues. Okay, so let's finish for today. So thank you for joining. So I hope that we will meet next month. We have to presentation. We have a presentation to agree and then prepare, and then we will announce. And of course, if you want to join and if you want to present something, then please so talk to us and just write I know private message through Meetup, or you have I can also put emails to me, and yeah, so I think that there are various ways to contact us, so me or so Andrzej, Tomek, Łukasz, whenever actually, and we can organize and also help you with the preparation. Okay, so thanks for your time. Sorry for my voice problems, and okay, so see you next time.